now that we know what work is, we can define, we can make our definition of energy make sense. Everybody together, what is energy?
The ability to do work.
Yeah.
Right, the ability to do work. Do you all have energy right now?
Yes.
Yeah.
Somewhat.
Somewhat. You're drinking tea, that should help you, right? Okay. So, energy is the ability to do work. Energy is the ability to do work. So, energy is the ability to apply a certain force over a given distance. So, in this sense, energy and work are synonymous. So when you calculate how much work it took to do something, it's just like saying how much energy did it take to do something. So the units for energy, units for energy are in joules, Joules. Symbol is J, joules. Now let's talk about another definition of energy, which is getting more to the point, because energy is a really, really fundamental concept in physics. And interestingly, as far as I know, Isaac Newton didn't know about it. Do you guys know that? Yeah, you would think he would have known about this, but this type of thing was discovered a little bit later. Now, let's talk about energy. So energy it's the ability to do work, but there's another way of talking about it. And this gets to a really important concept in science, which is whenever you do physics, you are looking at a closed system. Let me show you what I mean by that. You are analyzing what happens inside this box. You don't care what happens outside of this box. The problem you are trying to solve is in this box. Okay? So let's say you have a pendulum. And it's swinging back and forth inside this box. You're not concerned with the fact that there is I don't know, a person standing here who's jumping up and down. Okay? You only care about stuff inside the box. Now, say, for example, say you're studying the temperature of, well, let's see. Let's do it like this. This will start to make sense as we go through this example. Let's say you have 2, 3, 4, 5, 6, 7, 8, 9, 10. You've got 10 blocks inside this box. And this box, and I'll use the famous example from Richard Feynman. Okay? He talks about, what'd I do? Okay, sorry guys. I'll use the famous example from Richard Feynman, who is our friend and very famous physicist. He talked about Dennis the Menace. So here's Dennis, and he's in his room, and he's got 10 blocks. And his mom knows he's got 10 blocks. And so Dennis decides to hide some blocks under his bed. So here's his bed, and Dennis takes 2 blocks, and he hides them under his bed where Mom can't see him. So Mom comes in the room, says, Dennis, you've lost 2 of your blocks. But she, being very shrewd, knows that that blocks can't be created or destroyed. There's a fixed number of blocks. So she knows they must be somewhere in the room, and she eventually finds them under his bed. So they're accounted for. But he's going to leave them there under his bed. Then Dennis says, well, she found those blocks, but maybe I could throw some blocks out the window over here. So here's the window to Dennis's room. So he takes a block and throws it out the window, and it lands in the lake outside, and it sinks to the bottom. So erase a block. In fact, let's say he throws 2 blocks out the window. So we've got 2 blocks down here. Now you're going to say to me, well, you can't deal with anything outside the box, so what do we do about that? Well, we can. We can say, as long as we account for things leaving the system and things entering the system, as long as we account for things leaving the system or things entering the system, we're okay. So we can go like this. We can say the number of blocks, B, equals the number of blocks on the floor plus the number of blocks underneath the bed plus the number of blocks in the lake. Okay? So we can, as long as we account for blocks that are thrown out the window, we're okay. We can have things leave our system and come in just as long as we take care of it. So then Dennis decides to get really nasty, and he says, well, you know what? I'm going to burn some blocks up. Okay? So he lights a match, and he lights a block on fire, and the block gets burned up. Okay? Well, Dennis's mom is a very... Did I erase a block? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah. So Dennis, wait a minute. 5, 6, 7, 8, 9. Okay, so I erased the block. So Dennis's mom, she's really onto him now, and she kind of figured he might do something like this. So she very carefully measures the temperature. Well, she didn't even have to measure the temperature. She measures the mass of the gases in Dennis's room. Okay?
Very scientific.
Yeah. Yeah, she happened to measure the mass of the gases. So the number of blocks plus the mass of the gases before he burned the block, it would be like this, sorry. Yeah, measure, yeah. The mass of the gas after minus the mass of the gas before divided by the mass of the block is going to say how many blocks Dennis burned. Okay? A block, for all intents and purposes, still exists, right? So so finally, Dennis realizes there's nothing he can do to these blocks to really make them go away. His mom is always going to know how many blocks he started with and how many blocks he still has. So, okay, we get this idea that you have a fixed number of blocks. Energy is the same exact way, and it is associated with a law of physics called the conservation of energy. And this is a cornerstone of physics, and it basically states that energy cannot be created or destroyed. So your ability to do work, you can never make more of it, and you can never have less of it. It cannot be created or destroyed. This is a very, very fundamental concept. we will talk about it in the next lecture.